Hello, my name is Cody Allen, and today I will share with you information on the Cassini-Huygens mission. This information was gathered by myself, Harvey and Sydney Lyda. The Cassini satellite was a massive undertaking. From its sheer size to the amount of distance it has traveled to the amount of data it has gathered, everything about Cassini is big. Here you can see in the figure that Cassini has executed over 2 million commands, collected over 514 gigabytes of data, and traveled over 2 billion miles in its lifetime. The Cassini satellite was named after Jean-Dominique Cassini, an astronomer whose most notable achievements are the discovery of 4 moons of Saturn and the gaps between the outermost rings. The Huygens lander, destined for the surface of Titan, was named after the astronomer who discovered Titan, Christian Huygens. The Cassini satellite was expected to orbit Saturn for about 4 years, however, it is still in orbit today. The Huygens lander is still sitting on the surface of Titan. It took Cassini a total of 7 years to reach Saturn. The journey involved 2 gravity assists of Venus, 1 of Earth, and 1 of Jupiter. During this time, Cassini took many detailed images of these planets as well as Earth's moon and several asteroids. In this figure, you can see the orbital plan for this mission in an isometric view of the solar system. The Cassini spacecraft had many major components that made up the satellite as a whole. However, some of the most prominent are the propulsion system, the communication system, and the power system, and then the largest component by far being the Huygens lander itself. Cassini's movements are governed by its main engine on the bottom of the craft and several groupings of directional thrusters positioned throughout the structure. The main engine is used for large delta-V maneuvers, such as interplanetary stages, while the directional thrusters are more used for pitch, roll, and yaw, similar to an aircraft systems. Cassini maintains communication with NASA's Deep Space Network via its radio wave subsystem, as well as its antenna subsystem, which is made up of its high and low gain antennas. The high gain antenna is the giant dish that is most noticeably seen in any figure of the entire spacecraft itself. Cassini is powered by 3 radioisotope thermoelectric generators, which can be seen in the blueprint on the left. These generators are specifically run by plutonium dioxide, which is its radioactive material fuel source, which means that this system can run completely independent of any sort of sunlight, which removes the need for any sort of solar panels. By far the most ambitious component of the Cassini-Huygens mission was the landing of the Huygens Probe on the surface of Titan. This was the first time a probe was ever landed in the outer solar system. Once landed, Huygens was able to take over 37,000 images and record a surface temperature reading of -290 degrees Fahrenheit. In order to penetrate the thick atmosphere of Titan, Huygens was equipped with a heat shield much like re-entry vehicles from a low Earth orbit. In this particular case, the probe had to be completely encased within the shield so that it did not burn up in the Titan atmosphere. Once the Huygens lander had exited the thickest part of Titan's atmosphere, it was time to engage the Huygens Descent Control subsystem. This system was comprised of 2 separate parachutes, the first being used to slow down to Mach 0.6, and the other being smaller in order to speed up the descent due to limited battery life. Here you can see 3 sample photos that Huygens took once it landed on the surface of Titan. On the left, you can see what looks like a vast expanse of rock and sand. In the center, you can see a more distorted image, which could be due to the camera function. However, it is also thought that this could be weather interference, such as a storm or something of the sort. In the picture on the right, you can see on the bottom portion that the image is broken up. This shows that at this time the camera was completely malfunctioning. This is a list of all sources used for referencing the pictures throughout the slideshow, and we thank you for listening to our presentation.